I was a grad student at UCLA, got a PhD in computer science. I was working with Leonard Kleinrock, who was one of the early internet pioneers. And he was very close with folks over at ISI since there was a lot of internet work that had gone on here. And a particular friend of his was Danny Cohen, who was a longtime ISI person. I didn't know Danny at all. My advisor said, you should go over to ISI and you should talk to Danny. So we met somewhere down in Marina del Rey at a local coffee shop. And I remember walking in, and immediately Danny, there was sort of no formalities, no niceties, just dive right into talking about technology. And I remember distinctly he had a napkin and a pen and just started scribbling on the napkin, drawing little graphs and pictures and things, and talking to me in his rapid-paced Israeli accent. I wasn't quite sure exactly what he was talking about. But eventually I sort of figured out, and he was talking to me about a new network, a new technology that he had been developing with some of his colleagues at Caltech. He just sort of, he was so excited and so passionate that it really caught my attention. And as we talked more, I realized that ISI was this place where people were building things. And I'd come out of a kind of a theoretical background at UCLA, but I was super excited about technology and building things, getting my hands dirty. And I realized that ISI was a place where I could do that. Danny was super high energy, always just a million ideas, talking a mile a minute, and incredibly, he was sort of a polymath in that he really understood and had crazy ideas or interesting ideas in all sorts of directions. I worked with him on taking multi-computer technology, sort of high-performance compute technology from Caltech, and he had the idea that instead of building a very small computer with a lot of tightly coupled components in a small space, if we could stretch the distance between those chips, we could turn it into a local area network. We could connect all the computers, say, at ISI. And that was just one thing. At the same time, he was working on, I'm sure, a half a dozen other projects. One of the ones that was really key was the Moses project, which was providing an opportunity for universities or small companies to be able to build chips affordably by collecting projects together on a chip or a wafer. Caltech was using that to be able to prototype their chips, and then eventually at a company that we started, we used Moses almost through the life of the company to be able to do that. So the sort of the breadth was, to me, was astounding. But he was a joker, clever, always looking for fun, always engaged, and just a great person to work with. Obviously, ISI had been around for a long time. They were key in sort of the early parts of the internet. My interest and my connection with Danny was really to try to take networking, local area networking, not the internet so much, but more close-in networking, and move it to much higher performance. So the idea was to, at that time, Ethernet had existed. It was maybe running at, say, a megabit per second. We were developing a network that was hundreds of megabits per second. So the idea was to take these really big leaps forward into the future, try to figure out where we should be, and deliver technology and capability that was beyond what people had. The environment at ISI was really interesting, really fertile, especially in the networking space. We had people coming back and forth from USC working at ISI, but the internet and what the internet could do, this was pre-World Wide Web, this was pre-dot-com revolution, but a lot of people at ISI could see where the future was going to be, how the internet was going to be much bigger. It was going to be much more ubiquitous. There were researchers working on, Danny himself was working on voice and video over the internet long before Skype and things like that existed. So it wasn't obvious at the time that we knew where the world was going to go, kind of the insanity that we've gotten to, but lots and lots of smart people working together. And interesting, I think one of the important things was a lot of government funding supporting that sort of growth and sort of technology development in the internet space, I think was really, really important. The work that I was doing with Danny was coupling a project that was a DARPA-funded project at Caltech, which was doing, sort of high-performance computing. And Danny had been very good friends with Chuck Seitz, who was the professor there for many, many years. And they together decided or thought that there was an opportunity to really advance networking in general. And so Danny started working closely with Chuck. We took chips from Caltech and put them together in a local area network, which we built out at ISI. We actually ran the computers at ISI using this new prototype technology. It sometimes worked, it sometimes didn't work. But what was great about ISI is that they really understood networking technology on the host to get data out of the machines onto the network. And so there were a number of folks who were able to help take that prototype technology and actually productize it and make it work and make it robust. A lot of work in the internet space, being able to fail over from one network to the other, which really made experimentation and prototyping with the technology possible. John was running the division at the time and was sort of this legend already at that time. An amazing person, deeply technical, very interested in what we were doing, and just a great human, very kind, generous. I remember his office looked like mine now. He always had thousands of papers on his desk, but he always seemed to know precisely where the right paper was when you'd go in and talk to him about some piece of technology. And he'd say, "You should read a paper by," and he would sort of grab the stack and pull something out of the middle and hand you a paper that was really important and related to something that you were working on. But he was a great mentor, but just especially great at kind of pulling everybody together. And I think one of the things that was great about ISI, at least the time I was here, is I didn't feel like there was a lot of competition. Sometimes I think in the academic space, especially in those years, there was a lot of sort of people had to claim areas and make sure that it was theirs or they were given credit for it. And I really felt at ISI there was a lot of collaboration, a lot of people working together, a lot of overlap between projects, which I thought was really valuable for moving the technology forward. So one of the exciting opportunities for us here at ISI was that we could design and build our own chips. More importantly, there was the Moses program here that Danny had helped start, which was basically a way for research groups across the country to be able to design chips, university students, graduate students, professors, and instead of having to pay huge amounts of money to build, certainly to build a fab or to build lots and lots of chips, they could collaborate. Moses was a place where people could collaborate. They could bring designs together, put them on the same chip to reduce costs, make it easier for researchers to be able to deliver technology. So what we were doing was working with Chuck and his team at Caltech, and for many years they had been designing multi-computers, had been using Moses here at ISI. They could deliver the designs to Moses. Moses would figure out how to package them up, put them onto wafers, get them manufactured, get them sliced and diced, tested, put onto chips, and then delivered back to either ISI, Caltech, or other universities across the country. Prior to that time, there had been a really seminal book written about VLSI design, and there was a real revolution, I think, in the 90s, or maybe even a little bit earlier, in allowing students and others to be able to design chips and really sort of innovate in the technology space. Moses really allowed, in an affordable way, allowed people to do that. What we found later on when we started a company was that Moses was still a fabulous place when we were trying to move from being a smaller company to a larger company, we actually found that IBM and TSMC and the large foundries that make chips really weren't interested in small companies. And so the fact that Moses was here gave us the opportunity to grow our company from sort of nothing to actually pretty significant volume. We were spending most of our time in the networking space. So definitely the Caltech team was looking at computing and improving computers. So they were building technology where they could gang a lot of small chips together to make a much more powerful computer. In order to do that, the chips had to talk to one another. So there was a little communication link, if you will, between the small chips. The innovation that started here at ISI was to recognize we could leverage that technology to build really high-performance networks. And literally what Danny was doing just before I came, and then we continued together doing, was to really stretch the distance that you could send that technology. We were delivering, at the time, we were delivering something that was really 100x faster than networks that you could find today, which meant we could deliver a lot more data between machines. This was, again, before video and audio and things like that over the internet were big, but being able to move to 100 times faster networks allowed things like that to work and work well. And we collaborated some with folks at ISI who were working on video and voice, and we were able to run their technology over the new network that we were building. So we were moving, sort of leaps and bounds ahead of others in the commercial space and the research space in terms of performance and speed on the network. Yeah, the big idea that we had here at ISI was that networking could move well beyond where it was at the time. Literally 100x improvement in capability and technology. And by doing that, we actually didn't know where we were going to go or what it was going to do. It wasn't as if we could really see the future and all the spin-offs and the sort of collateral value you would get out of that kind of capability. We delivered the technology, the high-performance networking, and we worked with a lot of really smart people who were able to take it to different areas or new levels. Again, the base technology is really what you see in every data center that you walk into today. We didn't know it at the time, but that's kind of the natural evolution of the technology. A lot of work going on at ISI that I was sort of peripherally aware of was, of course, the voice and video over the internet. By having a higher performance network, you could send higher quality video, higher quality audio. And so I think the connection between the higher performance networking and the media that people eventually wanted to run over the internet, I think were big ideas that ISI was part of, and we were able to kind of co-evolve the network and the capability and the interesting applications over the top. At ISI, what we'd done is we built a small network. We called it the Atomic LAN. At the time, a networking technology called ATM was all the rage, and many of us at ISI and other folks in sort of the internet space didn't think it was going to go anywhere, but it was what the government at the time and others really thought was going to be there. So Danny, in a little bit of a sort of clever marketing, decided that we should call our network Atomic, which was ATM over Mosaic. Mosaic was the name of the multi-computer that came from Caltech. Even though we didn't actually care about ATM that much, nor did we think it was going anywhere, it was sort of the right branding, if you will, for us to develop our network. So we had built out a very small local area network here at ISI. We were actually connecting Sun workstations together. And simultaneously, sort of Danny and Chuck had been thinking about, is there something here? Is there something that we can do to commercialize it? And really what happened was, after I was here at ISI for a couple of years, we developed the technology. It seemed solid enough that there was something there. A number of Chuck's students, 5 or 6 of his students, Danny, Chuck, and myself, started a company called Miracom. It was 1994, April 1st, 1994. We founded the company out near Caltech, since most people were there. and we really commercialized what we had developed here at ISI, the networking piece. What was interesting and the key kind of ISI innovations were really the networking, the inter-networking, IP networking, which obviously ISI had a lot to do with. The Caltech folks were incredible computer designers, but they weren't really networking folks. Danny really brought the networking aspect to them. So we started, again, in 1994. Within about 6 months, we had a viable prototype, working products, we had customers. One of the things that was great at the time was the government was continuing to invest in this space. So we had research contracts here at ISI. Caltech had research contracts from the government. And we were able to take those contracts with us to the company and sort of do the R&D under government sponsorship and then commercialize the technology. Initially, most of our customers were either government or military or universities. So ISI, UCLA, University of California, Berkeley, University of Illinois, a lot of research professors working on networking space started to use our technology. And one of the things that we did that was a little bit innovative at the time was to just open the software up and allow anybody to develop on top of the hardware. We thought the hardware was innovative. We wanted to give other folks a chance to write software. So ISI continued to be a very strong partner and a developer of a lot of interesting local area network technology. They were very helpful in productizing and making sure that the technology worked well. They actually ran the networking division here. All of the machines were using some of the original technology. And then at ISI, they continued to go on to use the technology to develop some innovative ideas in something that they called NetStation. The idea was to build your computer completely attached to the network. All of the subcomponents of it could be on the network, and you could collect together what you would call a workstation by grabbing resources across the network. Miracom focused on local area network for some time. We had a pretty good business. It grew quickly. But in those collaborations with universities, we discovered there was an alternate market, which was really high-performance computing. So again, we had a very fast network. And what the folks at Berkeley had done was to collect their computers together, use the high-performance network to allow that collection of computers to work together on one problem. They went on to win international sorting contests, and really show at that point in time that networks of workstations, smaller computers, federated together with a very high-performance network, could really outperform the Cray supercomputers and other sort of specialized computers and mainframes of the day. There were a number of startups that came out of Berkeley. One was a company called Ink2Me, which was one of the first and best search engines that was using this distributed computing technology. And so there was a period in the 90s where we really saw a shift from very, very high performance, big, so-called big iron computers to what we call rack and stack computers attached with this high performance network. And Miracom went on in the high performance computing space to be a very large leader in the interconnect for those supercomputers. And that was really the beginning of kind of what you see at Yahoo or Google or Amazon. They very rarely build really, really big computers. They're now today still building racks and stacks of computers with a high-speed interconnect between them. It's not a MirrorNet network. That company no longer exists, but we were really out front in showing that by providing a really capable high-performance network, you could leverage a lot of compute resources across the network to build a really spectacular computing engine, if you will. The company went on I was at the company there for 7 years or so, eventually moved on to Google. The company stayed in business for another 20 years or so. In the Los Angeles area, in the technology space, I felt as if we were fairly unique. I think Caltech had some spin-offs in the technological space for many years, but I was not familiar with them, and it felt like Southern California was very different than Northern California. Northern California, with Silicon Valley and all the venture capitalists, the mindset up there was much more to provide a lot of funding and go really fast, and crash into the wall at 100 miles an hour if your company didn't work well. Here, and this was I was just out of grad school, so it was the first company I started, but we grew very slowly. We didn't actually take venture capital. We were, as I said before, we were funded somewhat by DARPA contracts, but we took a little bit of seed funding, just $1 million at the time, from some angel investors, and we never needed funding after that. So, very different from what you see today, where companies are announcing their $100 million round of funding, and so on. So we started small, we stayed small. The company grew very well, even with, I think at the time I left, maybe we only had 40 employees, but we were doing tens of millions of dollars worth of revenue. So it was very interesting for me later on to move to Silicon Valley and start companies up there, where the idea was much more to invest early in the company, grow the marketing and sales folks even before you have a product to sell. And that was completely counter to what we had done at Miracom, where the entire company was technology experts, and we sort of slowly added the business expertise that we needed, the sales expertise that we needed, but we didn't hire real salespeople for 7 to 8 years. We were able to just sell the technology based on the value of the technology. Danny was an incredibly smart guy, creative, great ideas. I don't think he was a great businessman. He was wonderful to have in the company. He was a great technology driver. He definitely understood where we wanted to go, where the technology should go, and what the future looked like. He was sort of a futurist, I guess, maybe. But he was definitely not methodical and focused in a way that you might want for business. But that's okay. We had other people who were doing that, and I think his creative spark was key, obviously in the initial ideas, but as the company continued to grow, having him around and always pushing us into new directions, new places to go, I think was very important. The experience at ISI and building networks and building technology really got into my bones, and it really set me on a path to kind of continuing to want to work in the networking space, evolve technology, improve technology, do things sort of better, stronger, faster. I eventually landed at Google, where we developed some of the highest performance, largest data center networks at the time. Many other companies have gone on to follow in our footsteps, but it's really been an exciting opportunity to be able to really get my hands dirty and sort of move the world forward, move the networking world forward, at least in the sort of local area network data center space, tightly coupled space. As I was looking through some of the old ISI work related to networking and local area networking, some of the follow-on work that happened here in the NetStation project was this notion of disaggregating the technology inside the machine or inside the data center. And interestingly, we're still talking about those kinds of ideas at Google today. The idea of being able to share resources by putting them out on the network, not locking them inside a computer underneath your desk or inside a particular data center, was something that the folks at ISI, after I left, were experimenting with even in the 90s, and this is still something that we're looking at today as something that could be a good idea. One of the things that was, I think in retrospect, wonderful here at ISI was the openness of the research, the openness of the technology. And we talked a little bit about startups and the different culture in LA versus the San Francisco area. And there was the work that John and Danny and lots of others here did in the internet space, where it was collaborative, it was open, it was all published, is very different than I think what I see today, where everybody's trying to protect their idea or turn it into the next startup, or move from idea to commercialization as quickly as possible. We did do that with Miracom. We were very successful, but we were able to do that because there was this open collaboration between Caltech and ISI, between researchers at ISI. It was allowing ideas to flourish, and collaboration and coordination was just sort of accepted. I think the world maybe has gotten a little bit more inwardly focused, and there's so much sense of trying to create the next big startup or make the next $1 billion, that it's not clear to me that's necessarily great for ideas. I'm not sure that everyone at ISI was altruistic and trying to save the world or make the world a better place, but I do think that the proliferation of great ideas that came out of ISI, I think, were partly because we were not all trying to keep ideas to ourselves and then figure out how to make a buck out of it. We were working together in the spirit of moving to the future, and not, I'm gonna be the next billionaire or the next Bill Gates or the next someone. I think the technology future is bright. Is the future bright for the world? I think we're in a tough space at the moment, where people are fighting more than collaborating, but I'm talking more about the broader world and not the technology world. Technology is going to continue to grow. There's certainly challenges on scaling technology, and you've heard of the Moore's Law from Gordon Moore at Intel, which was generating sort of doubling the performance of computers every 18 months for many years. That technology has sort of slowed down a lot, which means people have to be a lot more creative about figuring out how to move the technology, move performance forward. Those are challenges, but I think a lot of people are addressing and overcoming those challenges. So I see that there's probably a bright future for technology.